Yeah, question 10. Find the values of A for which the following matrix is singular. For a singular matrix, solution for singular matrix, for a singular matrix. Okay, its determinants. Its determinants is what? Is 0. Its determinants is 0. So that means I'm going to have to change these brackets to this sign, a sign of determinants. K minus 6 minus 54 K equal to 0. That's for singular matrix. And don't forget, singular matrix is always must be a square matrix. Okay, the number of rows and number of columns must be the same. So get the determinant of this one times this one, that's a k squared, minus this one times this one, minus minus 54 times minus 6 equal to 0. That's a k squared. And then move this one to the other side, equal to what? 324. 324. K squared equal to k is 4. That's k is equal to what? 18. We take the square root of both sides. So k is equal to what? K is equal to 18. Okay, so k equal to square root of 324. And that will give us 18. So that's that on this question. Question 11. Given that AB is equal to C, find expression. Solution. We're given this expression AB equal to B, and we're looking for this B only. Okay, so what we can do is to find a way of removing or cancelling this A. Okay, and by so doing, we are going to introduce inverse of this A. By the time we introduce inverse of this matrix A to both sides of the equation, this will be removed. This will be removed. So we now have this, and the inverse of matrix A has been introduced now. So by so doing, this what become identity matrix. Okay, and that become B equal to what? A inverse. Okay, so what we're going to do, we already have an expression for B. So what we do is for us to generate a value for A inverse. A inverse for 2 by 2 has this process 1 over determinants into brackets your 2 by 2 matrix. Okay, for a 2 by 2 matrix, you interchange what you have here. 7 will go here, and 2 will come here. So we have 2, we have 7 here, the 7 here is coming here, the 2 here is coming down, the 2 here. And then you multiply whatever you have on this side by minus times minus times minus. That's 0, that's minus 10. So that's how to do your inverse matrix for 2 by 2. You move this one to this place, you move this one here down, and then you multiply this one by minus. Minus times minus times minus. Determinant of A is equal to 2, 0, 10, 7. And you go this way, this one times this one, that's 14, and then minus what? 10 times 0 is minus, that's 0. The determinant is what? Is 14. Okay? So, the A inverse now is equal to 1 over 14 into bracket 7, 0, minus 10, and then 2. That's my determinants for A. Okay? Then the expression for B will now become 1 over 14 times the matrix and then times the matrix C. Okay, so let's do the multiplication. That will be equal to 1 over 14 in brackets. I've told us that when you are multiplying is row against a column. 7 times 16, that's 112, 112, and then plus 0 times 108, that's 0. So I'm true for the first element of the matrix. So I'm going to repeat it also again the second column and get the second element. And that will be 7 times 2, that's 14, then plus 0 times 24, that's 0. Also, the same row against the third column, so I can generate the third element of the matrix. 7 times 0, that's 0, plus 0 times 7, that's also 0. Okay, so I'm true for the first row. The second row, you repeat the same process against the first column so as to generate the first element in the second row. Minus 10 times 16, that's minus 160, and then plus 2 times 108. 2 times 108, that's 216. Okay, same also, minus 10 times 2, that's minus 20, plus 2 times 24, that's plus 48. Same row times the third column, minus 10 times 0, that's 0, plus 2 times 7, that's 14. So we now have 1 over 14, 112 plus 0, that's 112, 14 plus 0, that's 14, 0 plus 0, that's 0, minus 160 plus 216, that's 56, minus 20, 112 divided by 14, so I have 8, 14 over 14, that's 1, 0 over 14, that's 0, 56 over 14, that's 4, 28 over 14, that's 2, 14 over 14, that's 1. And that's end the question.